All right. Up next, we have Andy Bryant from the National Weather Service.
All right, good morning. I've been wondering what it looked like up here, so now I finally get to see. So I want to bring maybe a little bit different perspective from what you've heard over the course of most of the past 2 days. With the National Weather Service Weather Forecast Office in Portland, I am in a role called the service hydrologist there, but every weather office is, maybe not surprising, primarily composed of meteorologists, and we're very operations driven. We are very focused on whatever's going to happen in the next 7 days, forecast for all kinds of different partners, and then especially focused on, are there any types of weather that could potentially have an impact in terms of safety or property, those kind of things. So, So I'm just very interested to learn as much as I can being at the symposium because we're trying to figure this out. So here's just an overview of what I'm going to talk about our mission, and then every time I refer to this new hazard, I know it's not a new hazard, but kind of in recent history for the Portland Weather Office, it feels like a new hazard. So I'm going to talk about some of the things that we're doing to try and maintain awareness and communicate about the potential threat of flash floods or debris flows. Show some examples of how we communicate. I want to talk a little bit about what are some of the tools that we're using to try and assess the threat of heavy precipitation that could potentially be a driver for flash floods and debris flows from these burned areas over the course of the next 7 days. And then also how we're trying to better refine, within these burned areas, where are the parts of that burned area where we'd potentially see impacts. And we're very interested in the work that Ben's group is doing, what we're going to hear from Dogami and the USGS. That all has a bearing on what we're trying to do at the Weather Service. So I wanted to just talk about the mission. In addition to being very operations driven, we're very mission driven. Everything that we do for weather, water, and climate forecasting is driven primarily for protection of life and property and enhancement of the economy. And so the fires, starting with the Eagle Creek fire in 2017, and then especially with the fires in 2020, and then again the Cedar Creek fire in 2022, brought kind of a new hazard to Northwest Oregon. Certainly across the western U.S., we've been dealing with this issue increasingly over the past couple of decades, but we've kind of been insulated in Northwest Oregon and most of western Washington, watching the rest of the West burn and deal with these debris flow issues. So now we're having to deal with it. And so, in addition to not having dealt with these burned areas historically, flash flooding is really not something that we deal with in Northwest Oregon when you compare to other parts of the United States, and even across the western U.S. We just typically don't see the rainfall rates and the response to generate what most people would consider flash flooding in our area. So I'm going to, again, talk about how are we trying to communicate to our partners since we're all dealing with this, what feels like a new hazard. And so one of the things that we decided to do following the 2020 fires is to do a weekly overview that we send out every Wednesday. And I'll have my email address at the end of this presentation, so if you would like to be added to that email distribution, just let me know and I can do that. But basically, we're trying to highlight over the next 7 days, are there any days that we're particularly concerned about? And we're looking at both in terms of the certainty in the forecast for having heavy precipitation and the potential impact of that. See if there's anything else I want to say about this. I think that's just basically a heads up, and again, trying to kind of build a baseline of, what do we really need to be concerned about in terms of heavy precipitation. In addition to the text and the matrix, we'll typically add graphics such as this that just show various, ways to communicate this concern about heavy precipitation. We're also active on social media, both sending out our own messages, amplifying messages from other agencies like Dogami, trying to help folks in the public be aware of this ongoing threat in our area. So, all right, I want to shift gears a little bit and just talk about, so we're sending out this briefing on a Wednesday, looking over the next 7 days. How are we making that assessment? And trying to go from storm scale down to burned area scale or watershed scale is really difficult to, try and come up with a forecast with any accuracy. So this is just kind of a conceptual example of what we use for our meteorological models ensemble guidance. So basically taking, a couple different primary models and tweaking some of the initial conditions and producing an ensemble of answers. So the idea here is across the top, this is for one location, running, showing all of the different ensemble members, and then looking at the progression of time. And so at any 6-hour interval, then we can produce a graph like the one at the bottom that shows the probability of precipitation exceeding different thresholds based on that range of ensemble guidance. So there's a lot of possibility, a huge range of possibilities, so that complicates the difficulty in making these assessments. Just another example of this, breaking it down to even an hourly time scale. So for the nearer term, on the order of 48 hours, we have hourly guidance that we can look at. And that's, when we're talking about heavy precipitation that could trigger a debris flow within a burned area, it's that hourly or even sub-hourly rain rates that, really seem to be the driver for debris flow. So just another example of this ensemble guidance that we can look at to try and get an idea. And, when I think about historically, in my time working at Portland over the past 20 plus years, we had some events from about 2005 to 2015, several heavy rain events that, I think if any one of those happened on our burned areas that we have now, I think we would see pretty significant debris flow impacts. It's, as Ben mentioned, some of we haven't had a lot of cases of heavy rain to study. It's actually been kind of remarkable how few heavy precipitation events we've had over the burned areas since those fires occurred. I think the gorge has been the kind of the exception to that of seeing some more significant heavy precipitation events there. But this is the kind of guidance that we can see over the next couple of days for these hourly intervals. Just another way of visualizing that, a progression of 3 consecutive hours, looking at hourly rain rates moving through our area. We're also, looking at tools being developed by, this is from the Center for Western Weather and Water Extremes down at Scripps Institute. They're doing a lot of research on atmospheric rivers, and for Western Oregon, Northwest Oregon, Western Washington, that's our big driver for heavy precipitation events. So they're developing tools to help us better assess the threat for heavy precipitation. So then I want to talk about, okay, what about in more near real time? How do we assess the threat? So we've heard a little bit about, monitoring stations on the ground. There's various tools that you can look at online to see the network of existing near real-time gauges that are in operation. We've added 3 of those following the fires. We've got one in the Holiday Farm fire, the Gate Creek watershed that Mark Rivers from Weyerhaeuser highlighted yesterday during his talk. We've got one at Ripplebrook Ranger Station in the Riverside area, and then one down in the Beachy Creek fire area. But there's never enough gauges on the ground when it comes to monitoring precipitation. So we're also relying on our radar estimates of precipitation. That also has its issues, especially when you get down into the central and southern Willamette Valley because of the distance from the radar. So we're trying to use all those available tools, make assessments. So the example on the top is from the radar reflectivity from an event in September of 2020 that if it was just a little west of the burned areas, we feel pretty confident that if this had happened over the burned areas, we would have had some impacts. And so the radar loop on the top, and then a tool that has just been implemented within the last few years, developed by the University of Oklahoma at our, I think at the Severe Storms Lab, that takes that radar information and then tries to assess the hydrologic threat from that. So if we see we feel pretty confident within the next several hours that we do have a threat of flash flooding or debris flows from these burned areas, what do we do? So we would issue a flash flood watch that would highlight probably a pretty large area, maybe all of encompassing one or multiple burned areas, and that would be issued maybe hours ahead of time to highlight the threat of debris flows and flash floods. And then if we feel like, okay, there's precipitation happening now that could generate debris flow or flash flood, then we would issue a warning for that. So just showing an example here. I know the background map on this is not super helpful, but it's basically, highlighting just a portion of the Eagle Creek burned area. And this was, I believe, the same event that led to that fatality that occurred in the debris flow on the frontage road adjacent to Interstate 84. So we're also, like I showed it in the overview at the beginning, trying to refine the threat area. So this is an example for the Riverside burned area southeast of Portland. So on the left is all of the burned area, showing the burn severity, and this is the USGS guidance on debris flow probability. And then on the right, then just trying to highlight within that burned area, what are the watersheds that would potentially impact infrastructure and any kind of populated areas or highways or bridges, that kind of thing. I think about this and we're trying to refine the threat area, but the reality is, again, trying to go from storm scale to watershed scale, I'm like, well, we're working on it. It's a work in progress. So where are we now? Definitely through engagement with partners like you all. We are more prepared now than we were a couple of years ago. A lot of coordination ongoing, trying to think through, working maybe with a county emergency management department saying, okay, if we issue a watch or we issue a warning, what are folks supposed to do? how do you take action based on that? So those are the things that we're working out. A lot of uncertainties remain. Like I said, one of the issues is that, you can look at it fortunately or unfortunately. We haven't had a lot of major precipitation events to really test out, kind of the upper ranges of heavy precipitation. I think there's a question of the combination of, if we have a heavy precipitation event over the course of 12 to 36 hours, one of our kind of big atmospheric river events, and then maybe within that you have some sort of convective precipitation enhancement that generates short-term heavier precipitation rates. How is a burned area going to respond to that? We know throughout our area, even without the burns, we have these threats of landslides and debris flows. So trying to understand those precipitation dynamics and the connection to those debris flows is what we're trying to learn about. And then, I think the other thing is how does this threat evolve over the next few years? Like Ben mentioned, we've seen a lot of revegetation in these areas of, grasses and shrubs and some small trees. But, I think one of the other questions we've had is, especially in the areas where we haven't had salvage harvest, such as in the Eagle Creek burned area, pretty much that area is a lot of that is wilderness area. So you have all of these dead trees that are remaining in place. What happens to those over the next few years? And, the picture I had at the very beginning was from November of this past year, a debris flow that happened in the Riverside burned area. A lot of large trees in that debris flow content. So, what happens to those trees over time? How does the threat evolve? What kind of changes do we need to make to our services, to our partners as we go forward with that? Just some ways for you to stay informed. If you're interested in monitoring this more actively, operationally. So some URLs across the top for the various weather offices serving Oregon. The weekly overview that I talked about that we do out of Portland, we initiated that again because of this being kind of a new hazard for our area. The other offices serving Oregon, Medford, Pendleton, and Boise, Idaho, aren't doing that same kind of a weekly briefing for burned areas, but they certainly do email briefings or webinars to highlight any potential threatening events, along with all of the watches and warnings. And then I wanted to highlight this service, INWS, that is not for the general public, but you can register for a free account if you are an agency or institutional partner, and you can customize the areas that you want to be notified about and the types of hazards that you would want to be notified about. Just some links for learning more on this topic, and a picture from our Gate Creek weather station. Mark Rivers actually took this picture of us, a couple of folks from our office that went with me to that site. If you have any follow-up questions or you want to be added to that email distribution list, my email address is there on the bottom left. So, thanks.
We have time for a couple questions.
Everybody wants to go to break. I see one in the back there.
Thanks for the talk. What do you guys, so this is an area that doesn't have no applicable and really good current center for some of these different rates. Do you guys have something internally that you use for rainfall?
So the question is about there's assessment for most of the U.S. called the Precipitation Frequency Atlas. And for whatever reason, that never got updated for the Pacific Northwest. It was a funding issue. That is actually going to be addressed. The funding mechanism has changed, and that's going to be done for the whole country over the next few years, both precipitation frequency and probable maximum precipitation analysis. So really the guidance that we're using for assessing the debris flow threat, flash flood threat, is the rainfall thresholds that were modeled by the USGS, and we're super interested in all the research work that's going on to better refine, our understanding. We have those precipitation thresholds, but I don't think anybody feels real confident that those accurately depict the threat for Northwest Oregon. But that's what we have to work with right now. Cool, thanks.